So what about now? Now we have algebraic expressions, and we're asked to do different things. In this situation, we're asked to add. And so as we add these two together, we combine like terms. 8x squared of the 2x and negative 10x make negative 8x, and negative 5 and negative 9 make negative 14. Now some people say, well, you can factor out a 2 at that point. The directions do not state factor. So some people say to factor out a 2. The directions do not say to factor. Okay? That's a request that the directions will make. The situation just says perform the indicated operation. Your answer is fine. Factored form is not necessarily simplified. Here you multiply because it says perform the indicated operation. The operation is to multiply. 4x times 2x is 8x squared. 4x times 7 is 28x. Negative 2 times 2x is negative 4x, and negative 2 times 7 is negative 14. Combine them together, 8x squared plus 24x minus 14. If you factored it, guess what it would come back to? It would come back right to that. I know that we know how to do that. It's shown right from the beginning. So don't factor it in that situation. All right, here we need to distribute the constant, and we get negative 6x squared plus 3x minus 9. Here we distribute the negative 4. Okay, so we have negative 16x squared, positive 20x, and then a minus 4. Combine your like terms, negative 22x squared. The 3x and the 20x make 23x, and the negative 9 and the negative 4 make negative 13. So there we have it combined. Letter E, if you see the square, please do not write 9x squared minus 16 or plus 16. You need to multiply this out. 3x minus 4 times 3x minus 4. And when you see that, the 3x times the 3x is 9x squared. 3x times negative 4 is negative 12x. And negative 4 times 3x is negative 12x. Negative 4 times negative 4 is positive 16. So you can see we have 9x squared minus 24x plus 16. And there is our result. Here, if we distribute the negative 2x cubed through, we get negative 10x to the 5th. We get negative 6x to the 4th. We get positive 2x cubed. Is that right? Yeah, very good. All right, so we go to the more challenging one. So how do you handle that? Well, if you don't know how to do a problem, do an easier problem. Say it was x squared times 2x cubed minus 3x to the 5th. Well, in that situation, you would just do 2x to the 5th minus 3x to the 7th. That's easy. So all that's messing you up is that you got these fractional exponents. So if I write it as x to the 3/2 times 2x to the 1/2, 2x to the 1/2, minus 3x to the 5/2. Okay, notice that the root is the half part. So for example, if you had x to the m over n, that's the same as the nth root of x to the m. So the numerator stays with the exponent, and the denominator tells you that the type of index for the root that it is. So now we want to go ahead and make some hay here. So when we multiply, we add the exponents. 2x to the 3/2 plus 1/2 is 4/2. X to the 5/2 and x to the 3/2, this could be x to the 8/2 or x to the 4th. So we multiplied those through, and that's what we get. Something you love to do is you love to factor. Here we could take out a greatest common factor, 2x squared, times, and if you take that out, you get a 2x minus 3. This common factor, we take out 3y, and you get 3y to the 3rd plus 1. You take a 3y, you get 1, because when you redistribute it back through, you have to make sure you come up with that 3y. Minus, it looks like we get a 4y. Okay, so that's greatest common factor. Trinomials are great because you can factor them very easily. We got x times x is x squared, and then two numbers multiplied, negative 33, that add to negative 8. Looks like we got a negative 11 and a positive 3. Ooh, here we've got x and x. Two numbers multiplied to negative 48. I'm going to go negative 16 and positive 3. That's going to work out for me there. What if we end up with lead coefficients that aren't 1? What do we do in that situation? Well, guess and check is a good option. I'm going to try 4x and 2x here. And I know I'm going to have a 3 and 1. I'll try the 3 here. That'll give me 6x. And the 1 here, that'll give me 4x. So let's try that. You know that the 3 times the 1 gives you 3. You know the 4x times the 2x is the 8x squared. Try the inside and the outside, and you do get 6x and 4x make 10x. Okay? So guessing and checking works really good. Some of you don't like to guess and check, and I like to do what I call the AC method. The AC method, you take A and you multiply it over to C, and you get x squared plus 10x plus 24. Now, don't lose me, folks. People sometimes worry. This is, I think, the easiest way to do the AC method. This factors to x plus 6 and x plus 4. Now, just ask yourself, what number did you remove from the beginning? We removed 8. Put it back. To simplify this, you know 8x times 8x, that's 64x squared. You need an 8x squared. So this is not right. How do we reduce it down? What are 8x and 6 both divisible by? 2. So 4x plus 3. What are 8x and 4 both divisible by? 4. So you got 2x plus 1. And you can see that that's how it factors. So we got two methods, guess and check or AC method. I'll do the AC method once more. I multiply that and I get x squared plus 7x minus 8. Factor. I've got a plus 8 and a minus 1. Now what number did we take out? We took out the 2. Put it back. What's the common factor here? Just 1, so it's 2x minus 1. Common factor here is 2. Divide it and you get x plus 4. So this is the correct factoring. Difference of squares, great way to factor. We have 3x minus y squared times 3x plus y squared. This one we're going to have x squared minus 1 and x squared plus 1. Now it's true that the x squared plus 1 does not factor. It doesn't. But this one does. X plus 1, x minus 1 times x squared plus 1. Cubes. The formula for sum and difference of cubes goes as such. A cubed plus b cubed factors to a plus b. Then we square the front. We square the back. We multiply the two together. Last part is always plus. This part is opposite what the first sign is. So, I see two cubes. Set it up. X and 2. Square the front to get x squared. Square the back to get 4. Multiply the two together, 2x. Okay, this is minus, so this is minus. This is always plus. This is opposite what the beginning is. Try it again. 8x cubed, got 2x. Y to the 6th, y squared. Square the front, 4x squared. Square the back, y to the 4th. Multiply the two together, 2xy squared. Since it starts with plus, it's plus. This is always plus. That's opposite what you started with. Couple more grouping problems. don't ever put a parenthesis in front of a subtraction sign. Rewrite it to be x cubed plus 5x squared plus negative x minus 5. You can put the parenthesis in front of an addition sign, no problem. Factor out an x squared, you get x plus 5. Factor out a negative 1, and you get x plus 5. X plus 5 can be taken out, and when you do, you are left with x squared minus 1. X squared minus 1 factors, so x plus 5 times x plus 1 times x minus 1. The next one, I like to start by taking out an x. And when I do, I get 3x cubed. I get 6x squared. I get 7x. And I get 14. I'll just always keep that x out front. From that part, I can take out a 3x squared. So x times 3x squared. I'm left with x plus 2. And I can take out a 7. X plus 2. Take out the x plus 2, and I'm left with a 3x squared plus 7. It is factored. Some of you factoring is very, very, very simple. I would like to take some of you, if you're kind of done and you just can't handle anymore, that's fine, but what if we tried a couple more challenging problems? Like this one. It has a rational exponent. No big deal. Hopefully you can see that the common factor in this situation is a 1 plus x raised to the 1/3 power. Okay? We factor it out. The question is, what do we get when we factor that out? When I factor it out of that, you know you're left with 1. But what do we get when we factor it out of that? Well, think about what happens when you factor. For example, if you have y squared minus y cubed, and you take out a y squared, you're left with 1 minus just y. What did you do? You took 2 minus 2 to get the 0, and then the 3 minus 2 to get the 1, right? We subtract the exponents. So when you take this out of that, you have to subtract. Negative 2/3 minus 1/3 is negative 3/3, or negative 1. So if you factor it out, you get 1 plus x to the negative 1, and then you have that x right alongside of it. So what does that look like then? Well, what it looks like is 1 plus x to the 1/3 times, this goes to the denominator, 1 plus x. This goes to the numerator, plus 1. That is the factored form. I know for some of you, it blew your brain. It looks tough, and it does. But you know what? If you watch it again 2 or 3 times, you'll probably really start to see it. Again, notice how I took an easier problem and tried to model it. This one's actually a little bit easier. Don't worry about it. This one is not shares a common factor, but I'm going to make it an easier problem. Say it was u squared minus 2u minus 3. Okay? So I'm going to take a tough problem, make it an easier problem. Notice instead of writing a squared plus 2a, I wrote u instead. Well, that factors to u minus 3 times u plus 1. That's easy. Well, what was u? U is just that guy, so dump it in here. A squared plus 2a minus 3 times, take u and dump it in here. A squared plus 2a plus 1. Well, what do you know? Those two things factor. They factor to a plus 3, a minus 1, a plus 1, a plus 1, or a plus 3 times a minus 1 times a plus 1 quantity squared. factoring techniques you maybe haven't seen before. Just kind of fun. I don't think you'd have to worry about seeing something like that on the test necessarily, but yeah, good stuff. All right, later on we're going to get to fractional expressions, all sorts of other stuff. Hopefully you've had a good time. I can't wait to see you in class.